Hello guys, welcome back to the channel. In previous video, we read about OSI model. We read about the various layers in OSI model, that is application layer, presentation layer, session layer, and all the way to physical layer. Alright, we read about that what does these layers do? What are the responsibilities that have been given to these layers? In today's lecture, we are going to look at what TCP/IP model is, that is transmission control protocol or internet protocol. Why internet protocol? Because this protocol is actually being used by the internet. It was developed prior to OSI model. That is the reason it is being used by the internet. It is being used by the internet. Now, what are the similarities between TCP/IP model and OSI model? So you can see here there are lesser layers than OSI model in TCP/IP model, whereas in OSI model there are application layer, presentation layer, and session layer. All these three layers have been combined into one layer, that is application layer here. So the responsibilities of all these layers are here handled by only this application layer in TCP/IP model. Moving down, there is transport layer, same as the transport layer in OSI model, and then network layer, that is also same as the network layer in OSI model. However, sometimes this network layer is called as internet layer in TCP/IP model, not in OSI model. It is here sometimes called as internet. This network is known as internet sometimes. Alright, you can also call it as internet. Then down here we have network interface. Data link layer and physical layer of OSI model is similar to this network interface. So the responsibilities that data link layer and physical layer take care of are here being played by this network interface. Alright, now in between here we can see there are some of the protocols. They are actually all the protocols that these layers use. So application layer TCP/IP model can use these protocols, and so on. We have the protocols used by transport layer, TCP, UDP, then network layer, then network interface. We're going to talk about all of these protocols in the upcoming lectures. For the time being, we were here to see what is the main difference between OSI model and TCP/IP model. And we discovered that these three layers are combined into one in TCP/IP model. Alright, now moving further, there is a term known as PDU, that is known as Protocol Data Unit. What is it? Now you can see here the data, whatever application layer will produce will be termed as data. By application layer I mean application layer, presentation layer, and session layer. You can see here whatever this layer is going to produce will be termed as data. This is very important, please focus. Now whatever the whatever the application layer will provide the transport layer. The transport layer is going to add the destination and source port address to it. After adding that is application layer is going to hand over this data to this layer, and transport layer is going to add or encapsulate source and destination port address into this data. Afterwards it will be termed as segment. Okay, application layer hand over the data to transport layer added or encapsulated the data with port address of source and destination, and that will be termed as segment. Alright, coming down, now this segment will be hand over to this layer, that is internet layer, or we can say network layer. As I earlier told you, sometimes in TCP/IP model we refer network layer as internet layer, and here we can see these layers are referred as network access layer or network interface layer. Alright, now we were saying that this segment will be handed over to internet. Now this internet is going to encapsulate this segment with, what does internet provides? Internet provides IP address. Hence it's going to encapsulate this segment with source and destination IP address. And once it's done with that, then that will be termed as packet. Alright. Now here in packet, when once packet is formed, now what the data link layer does, here data link layer is right. So what the data link layer is going to do, it's going to take that packet from the upper layer and then it's going to encapsulate it with header and trailer. All right. Now what does that header and trailer is going to contain? It will be having the source and destination MAC address and some other informations, but mainly source and destination MAC address. Afterwards, when we are going to hand over that to physical layer, it's going to encode the upper layers, whatever the upper layer is provided to it, into bits, that is 10 10 and so on. So these were the PDUs of different layers, that is protocol data units of different layers. Alright, so basically what they does is they take the data, or they take the data here from the upper layer, that is application layer. Transport layer takes data from the application layer, then encapsulates it with port address of source and destination. Then in internet layer, or the network layer, rather we should say network layer to make the understanding easier. In network layer, segment is encapsulated with IP address of source and destination. Then in the data link layer, it will be provided MAC address. So here was the simple data, then it was provided with port address, then it was provided with the IP address, then it is provided with MAC address, and finally when it has to be transmitted now, then it will be encoded into bits, that is 1010. All right, so this was about PDU, protocol data unit, and TCPIP model. All right, now moving on to what routers are. Now we are going to talk about what routers are. So basically, as I earlier told you, routers are basically intermediary devices that generally takes data from the server, and with the help of these routers we are able to get that data on our devices, on our end devices. So what they basically does is they are just transmitting the data from the internet to us. All right, so router can only work, rather router works on IP address. If router is going to find your device that this person is raising a request, then it is going to find you with the help of IP address. It does not work on port address or MAC address. You'll come to understand that later. Let's look here. It forwards data packets between computer networks, right? It's going to forward a data packet from one node to another. It could be another router to another router too, because if there's a lot of distance in between you and the server, then there are going to be a lot of routers. So then the routers transfer that data to other router, and that router will transmit that data to other router in order to get that data to you. And secondly, it's written here, it is connected to at least two networks. So it will be connected to at least two networks. That could be a LAN, could be connected to a LAN with the help of a router. All right, a LAN could be connected to a WAN, that is wide area network. A wide area network could be connected to a wide area network with the help of a router, or a LAN could be connected to an internet service provider. So these are the things that a router can do. Now it is a layer 3 device. What is layer 3? We actually count layers from downwards. So if we look at here, this is first layer, this is second layer, this is third layer. So what is the third layer? It is network layer. And as I told you, it works on IP address, and we know that network layer provides the IP address. So That is why it is a layer 3 device, because it works on IP address. It will find you with the help of IP address. That is why it is termed as a layer 3 device. Stores routing table. Now how it is going to find you? Suppose you are a law of quite a distance away. Now how it knows that to which router, to which next router it should transmit the data in order to create a best possible route to reach you? So there is a routing table stored inside that router, and because of that table it knows, it calculates actually which route is going to be the best. All right. And some another things about router are uh, that I told you that a router can transfer packets from for computer networks, and it connects these networks. It is a layer 3 device and it stores routing tables. Yeah, that is all about router. And moving on to repeaters now. So what repeaters are? The repeater, look, repeater is nothing, is going to do nothing, nothing that amplification or something like that. What repeater basically does is, it's going to regenerate a signal over the same network without modifying the signal, neither increasing the strength of the signal nor decreasing it. Suppose, why does we need a repeater? You know, when you look, I earlier a lot of times told you that our distances between a network and the server are quite a lot. There's a lot of distance. So over the length, the signal that you transmit gets weaker. Alright. And if it gets weaker, it may not reach you. This is why we need repeater. When we install a repeater, then what that repeater is going to do is that whenever it gets the signal, it's going to regenerate that entire signal again. Alright, without increasing the strength or decreasing the strength. It's just going to regenerate the signal so that it can reach you without getting weaker. Alright, so it is also written over here, data signals become weak over long distance. Repeater just regenerates the signal over the same network. It operates at the physical layer, it does not amplify the signal. Moving further, we have bridges. Now what bridge is? Bridge is also kind of a repeater. However, with being a repeater, it also has functionality of reading MAC address. So it's, what is bridge? It's just a repeater. However, it can also read MAC address. Alright. Now it is a layer 2 device. As I told you that layer 3 devices are IP address devices which are network, which belong to network layer. Now here layer 2 is data link. It works on MAC addresses. Hence the devices that work on MAC address are termed as layer 2 devices. Alright. Now it is a 2-port device. It has 2 ports to connect 2 nodes. Alright. 2 LANs maybe. Now it's written over here that interconnects 2 LANs on the same protocols. It can connect 2 LANs that are working on same protocol. Alright. So this was about bridges, what bridges are. Now there are 2 types of bridges, that is transparent bridge and source routing bridges. So first of all, let's look at transparent bridge. Now in these bridges, the stations are completely unaware of the bridge's existence. That is, no reconfiguration is required to add a bridge. I'm sorry I didn't wrote G here, it's bridge. Now what does this mean? It is that if you are installing a transparent bridge, the network, the nodes there will even not be aware that there is some bridge installed in the network. And because of this thing, we won't need to reconfigure any setting. Like we don't need to reconfigure that your route should be this or anything. No reconfiguration is required. All right. Moving further, the another type is source routing bridges. Now in these, The routing information is provided to the sender original source by these bridges. These bridges process the information and the routing operation is performed by source, the sender, and frame specifies which route to follow. So basically in this type of source routing bridges, what they basically does is they are going to first they are going to provide the routing information to the sender. Suppose my computer is sending some data to you and I am sending it to you via the help of there are some bridges in between. So what that bridge is going to do is it's going to send me, I am the sender, so it's going to send me the routing table. Routing information. Okay, and based on that information, I am going to perform the routing operation. I am going to choose what the route should be. Okay, so it's also written over here, which I read for you earlier. These bridges process the information. Routing operation is performed by source, sender, and frame specifies which route to follow. Then I will be telling you via the frame that you which route you have to follow. I will be storing that information in the frame that you have to follow this route. I am the sender. There is a bridge in between. The bridge is going to send me the routing information. On base of that routing information, I am going to provide you I am going to process what the route should be. That is, I am going to do routing operation. I am going, after doing that routing operation, I am going to store the data in a frame and send that to you. So with the help of that, you will be able to know, if you are you are a router, you will be able to know where do I have to transmit this and which route to follow. All right. So this was types of bridges, that is transparent bridge and source routing bridge. Now here we have different types of network devices. There is repeater, hub, switch, bridge, router, multi-layer switch, router, modem, firewall. Now let's look at repeater. You know what repeater is? We just now talked about it. Now talking about hub. What is a hub? Hub is just like a switch. However, the main you can say specification, rather saying main disadvantage of hub is that it always does broadcast. So suppose, let me just show you an image demonstration. Let me show you some devices connected with hub. Now suppose this is a small LAN. All right. Now suppose this is a LAN. Okay. If this is a hub, not being a switch, if it is a hub, then whatever data you're going to send this to send to this hub is going to do a broadcast. That means that data will be transmitted to each and every member of that computer network. And this is the major drawback that we face when we are using hub. However, that is not the case with switch. When you are using switch at the place of hub, you can do unicast. That is, whomever you want to send the data, you can send to that person alone. Your data won't be broadcasted without your wish, that is. Okay. Now bridge, router, we read about them. And there is a device which is multi-layer switch. It's a layer 3 switch. It is a layer 3 device. Now look, switch is basically a layer 2 device. That is, it works on MAC address. However, it's written over here that is a layer 3 device. So this multi-layer switch can do the functionality of switch to some extent. That is, it is actually a layer 3 device. It works on IP address, but it also can do the functionality of actual switch to some extent. All right. Now there is a router, that is bridge plus router. So it will be having the functionality of bridge as well as the router. Okay. Now there is a device known as modem. What this modem does, Look, the traditional telephone lines, which are only meant to transfer audio signals, they cannot transfer digital signals. However, with the help of this modem, after doing modulation of our digital signal, which this modem will do, modem is going to do modulation of our digital signal, and afterwards the modulation, those digital signals can be transmitted over those traditional telephone lines which were only meant for transmitting audio signals. And when they will be received by another the receiver. There this modem will do demodulation. Okay, so with the help of this, because of this, we can use telephone lines to carry digital signals which were not actually meant to go through telephone lines. However, after their modulation, we are able to do so. The last one we are going to talk about is firewall. There's an L here, I'm sorry about that. Now, what is a firewall? It's basically a security device which is just going to filter the data based on IP address, application data, and etc. So it just filters the data, whatever the data enters in the computer based on the IP address, application data, and many other things. It's going to filter that data. So these were some of the network devices which we read about. Now we are going to talk about physical layer. So as you all know, physical layer converts data into signals. So some fundamental principles of physical layer are: it moves data in the form of electromagnetic signals across a transmission medium. If you don't know what electromagnetic signals are, just don't bother yourself. Just imagine that they transfer this with the help of signals. If you are a non-medical student, you might be knowing it. So if you're not, then just don't bother yourself with that. Just imagine that it will move data in the form of signals across the transmission medium, and those signals will be electromagnetic. All right. Now, data cannot be directly transmitted, it has to be converted and coded into signals. Why? Now, why it converts into signals? Because data in its actual form cannot be transmitted over these lines, which are meant to carry electrical signals. They cannot carry the actual form of data. So this is the reason why we convert that actual form of data, why we encode that actual form of data into signals, so that those signals, those electrical signals, could be carried by the electrical lines to the receiver, and then those receive when they are received, they could be decoded into again its original form. So yes guys, this was all for today. I hope you enjoyed the session, and thank you guys.